All right, so let's talk about limits that involve infinity. Either we're, as x approaches infinity, so as we go to the outer bounds of our graph, that's the first part, finite limits as x approaches infinity. So what that means is we're approaching a number. As x gets bigger and bigger, we're approaching a single number. Perfect. Here you go. All right, so we use infinity to describe the behavior of a function when the values in its domain or range exceed the finite bounds. So just to be clear, this is as x is approaching plus or minus infinity. So this means we have a horizontal asymptote. So as x gets bigger and bigger, if we're approaching a single number, that means there has to be a horizontal asymptote there. So do you remember how we find horizontal asymptotes? Because we're going to discuss it today. Okay, so if, what? I'm just saying, do you remember? And think to yourself, if you're like, no, maybe make a note and be like, star, star. How do I find horizontal asymptotes?
It's the variable.
Leading term test. Yep. What? I don't know. Oh, leading term test? So here, would we have a horizontal asymptote? No, because the leading term is bigger than on bottom, which means we'd have a oblique asymptote. Oh yeah, because this is a line, literally. We have an oblique asymptote, it'll never get smaller than that. Whatever.
So what's
right.
the one that equals 0? Is it one?
So bigger on bottom.
Oh, okay.
Is it like Bilbo or something? I don't know, last year.
What is it when they equal?
Do you remember Bella had like this whole thing? Bilbo or whatever, like bigger on bottom, 0, bigger on top.
Oh my god, I forgot she was on top.
It's okay.
Wait, Bilbo bigger?
I don't know what it was. I don't know. Okay.
She was always sleeping.
So, horizontal asymptotes. The line y equals b is a horizontal asymptote of the line of the graph y equals f of x. So what this means is, as x approaches infinity, we're approaching b, or as we're approaching negative infinity, it's approaching b. So literally, this is a horizontal asymptote. So let's consider this graph below. X over square root of x squared plus 1. So if I'm looking at the leading term test, remember we're just looking at the variable with the highest degree on top, variable with the highest degree on bottom. So I have x over an x squared. Well, squared of a square root of a square. Well, this turns into just x over x. So leading term test says what happens as x approaches infinity.
It's 1 over 1.
So this just turns into 1. Oh, cool. So I literally have a horizontal asymptote at 1. So as I approach positive infinity, I'm approaching 1. As I approach negative infinity, I'm approaching, well, this is the graph of it, just FYI. So as I put in negative numbers into my, okay, on this left side, as I put positive numbers, I have a positive over positive. Cool. As I put in negative numbers, remember how we had a square root of a square? If I square a negative, it turns positive. So then I'm going to have a negative over a positive, so this would actually be a negative 1. We're approaching negative 1, the asymptote down here.
Well, we have graphs for this.
Thus, the graph of f of x has horizontal asymptotes at y equals 1 and y equals negative 1. Or, guess what? You could like simplify this and say y equals plus or minus 1. That's where it has its horizontal asymptotes. All right, so I think you had a question, but just hold off till we're done with the lesson if it's about the quiz. Use the graphs and tables to find the limit of my function as we approach infinity, as we approach negative infinity, then identify all horizontal asymptotes. Okay. So here I'm looking at the leading term test. So I have the biggest variable with an exponent on top is 2x. The biggest term, right, down on the bottom is absolute value of x. Well, absolute value of x doesn't change the exponent. It just makes x positive. So let's put absolute value of x. So when I insert a positive number, so this is part A. When I insert a positive number, so let's take the limit of f of x as x approaches infinity. So I have a positive over positive. All right, so this is the case when I have like, let's see, 2x. And if I take absolute value of a positive number, it's going to be regular positive. So that cancels out, and I see the limit's 2. Versus B I'm approaching negative infinity. So the reason I'm trying to be very clear with my absolute value is absolute value tells you your distance away from 0, and distance can never be negative. Okay, so now if I have 2, and this is now going to be a negative x, because right, we're going to negative infinity. I just want to make it clear that this top, when I put an x, is negative. We see the x's will cancel, but I'm looking at the SIGNs, the positive negative signs. And if I take absolute value of a negative, it turns positive. It's still like x over x, but if you're thinking as we go into negative x's, well, the bottom is absolute value, the negative will go away when I take absolute value of it. The top is negative, so this is why it's -2. I don't know how to like write this. I don't really want to write negative infinity over infinity. Ugh. So the x's go away and I'm left with -2. We see. Okay, let me be clear where I'm going with this.
So the signs
Okay.
don't really matter for the
The what?
The signs don't matter in crossing out in the leading term test.
The sign does matter. It's how we have the negative on B instead of A.
Well, I mean, like you still cross it out.
Oh, I still cross out the x's, yeah,
Okay.
because it's still the absolute value of x. Well, I still have a power of exponent of 1 inside. And then C, we want to find the horizontal asymptotes. Well, clearly, where are my horizontal asymptotes? Exactly, positive and -2. HA, horizontal asymptote, VA, vertical asymptote, just to be clear if I like write that on your paper. Okay, cool. So far, this is like mostly what we've done already. Yes.
What happens if you're trying to find the limits if the limits if the leading term test isn't fair equal on top of that?
Okay, so there's, thought I had it down here. Okay, it's fine. I'll just go through the leading term test relatively quickly. So, leading term test. Okay, what if I have x to a number over x to the same number as, see, limit as x goes to infinity. So if it's the same number, they'll cancel out and it'll just be the coefficients, the ratio of coefficients. So my example for this one is what happens as x goes to infinity of 5x to the third over 2x to the third. It's literally just going to be 5 over 2 because the x's have the same power, they'll cancel out. Okay, next example. So that's case 1 if they're the same. Case 2, what if we have bigger on top? Limit as x goes to infinity of x, which is big, over x, which is to the power of small. Well, guess what? This is going to be an oblique. Oblique, no horizontal asymptote. I think that's how you spell oblique. O-B-L.
There's no. I mean,
O-B, whatever. Whatever. Okay, oblique. Oblique. At an angle. Okay, so no horizontal. No horizontal. So my example for this one, what if I take limit as x approaches infinity of x squared over x to the fourth? Well, guess what? This is literally 1 over x squared, and as we go to infinity, it goes to 0. Damn it. I did say bigger on top. Ugh. Dang it. All right, x to the fourth over x squared. Well, this same thing as taking x squared, and if I'm going to infinity, this is just going to infinity. Makes sense. There's no horizontal asymptotes. All right, because it just keeps getting bigger, bigger, bigger. It doesn't like reach a number and like round out. Nope, it just keeps getting bigger and bigger. And then my third case is if we have smaller on top. So x small over x big. And this is where your horizontal asymptote is 0. So if I have x over x cubed, that's the same thing as 1 over x squared. So as my x gets bigger, I'm dividing by a larger and larger number. So if you think about it, 1/2, right? So 1/2 versus a third versus a fourth versus a fifth versus 6, right? As the number on the bottom of a fraction gets bigger, the overall number is much, much smaller. So I'm approaching 0. Because imagine having 1/10 versus 1/100th. It's much smaller. So as my number on bottom is getting bigger and bigger, the overall fraction, the overall number is getting much smaller. Okay, those are your 3 cases. That's it. All right, other properties as x goes to infinity. These are all the same rules of limits. So yesterday, one of our extra practice problems was the constant multiple rule. Remember how we did limit as x approaches 0 of 7 sine x over 5x? Like, okay, cool. I pull out the 7 over 5, and then I can take 7/5 times limit of sine x over x. So if you're multiplying by a constant, you can pull that out front. Same if you're multiplying 2 limits together, well, you can take limit of the first one and multiply by limit of the second one. And cool. You guys can read. I don't know.
That's what you think.
Okay, that was a bold assumption. I'm sorry I assumed you're literate. Cool. My bad. Okay. It's just, this is the exact same thing like we went over last year. Literally talking about these things, it's better if we apply it and do some examples. All right, so note, as x goes to infinity, what is the limit of sine x over x? That was as x approaches 0.
Silly.
Oh, okay.
You trick.
Infinity.
It goes
Zero.
between 1 and -1.
Well, I think, was that just a guess?
Because
No, because it
that'd be
It oscillates, but it gets closer and closer to 0. So at first it looks like this, and then it gets smaller and smaller and smaller and smaller, closer to 0. So it's approaching 0. Side note, let's play a little game called What If I Have Cosine of x over x. What's the limit of cosine of x over x? It's also 0. Haha. Okay. Because guess what? It also starts and then it dampens, it gets smaller and smaller, and oscillates around 0. It just starts in a different place. It's just a phase shift of pi over 2. Phase shift meaning horizontal translation A. Phase shift, horizontal translation is a phase shift of cosine and sine are phase shifts of each other. Okay. Example 2, evaluate each limit. So let's see. I'm glad we went over horizontal asymptotes and leading term test because now we're going to use it. Let's just start with Noah Anish. I'm just going to go down the list. How do I evaluate this limit?
Squared over x over 3 to the third power squared 0.
Yep, limit as x approaches infinity of x squared over x to the third. So we know this is literally going to be the limit as x approaches infinity of 1 over x. Remember what the graph of 1 over x looks like? Like
It's going down.
it's like a curve up here and like a curve down there.
yeah.
Like swoosh. Okay.
Aerobics class.
Why am I doing this? I could draw it. Ah! That's what it looks like.
You good? Yeah, I like the aerobics.
And we're adding to the dance moves.
Yes, the dance moves. Whatever. Okay, I look that dumb. I look so dumb. Okay. So clearly we see it's approaching 0. No was correct. Bigger on bottom, we're going to 0. Horizontal asymptote 0. The limit is 0. Yeah. All right. Let's do Ariel and do B.
Yeah. So it's the same degree. So you just do the coefficients over the coefficients over each other. So it's just 3 over 2.
Exactly. So coefficients 3 over 2. Awesome. Let's do C. Maya Hamides. Sorry. Okay. So leading.
No, I'm not confused with that. But like, when it says to evaluate limits, we're just finding the horizontal asymptote.
Well, right. We're finding the horizontal asymptote because as x approaches infinity, it will approach the horizontal asymptote. Horizontal asymptote is the limit as x approaches infinity. Because as we get bigger and bigger x, it gets closer and closer to my asymptote.
Also negative.
Also what?
Also negative.
Let's see. Right now, did I make it so we have a negative one anytime soon? So For this one, for b, it would, as I approach negative infinity, it would also go to 3 over 2. Because if you take a negative number and cube it, it's negative, and then divide by a negative number that's cubed, also negative. Negative divided by negative is positive, so it'd have the same number. If I look at the
No, I'm
left,
just asking if your limit is like,
if I would do it,
negative infinity, you're still like the horizontal aspect is still.
so this one it would be, because the graph looks something like this. Looks something like that. Sorry, this is not perfect, but you know what I mean. It's one of these. Something like that, where it's approaching the same number on both sides. Versus you can see with this graph, as I go to infinity, I'm approaching 0. As I go to infinity, I'm also approaching 0. All right, my almighty C.
Okay, so this is a little tricky. I believe that sine x over x can like equal 0, right? So that kind of.
Okay.
Clearly I'm wrong.
No. Okay.
I don't know what I'm.
It's a tricky question. This is unfair of me because I was like, here, baby carrot. Let me give you the whole thing. Like, oh my god. What if I tell you sum rule, right? What if I rewrite this? Maybe it'd be a little easier if I rewrote this so it's, a little separate. So if I add 3x over x plus, okay, so limit of this plus sine x over x. Wait, if I'm adding
And one of them.
two things,
Okay, so that's.
if I'm taking the limit of the, wait. Do you remember? Go to the top. Sum rule. What does sum rule say? If I am adding two functions, I'm wanting the limit, I can literally add the two limits together. Okay.
0 plus 3.
There's some rule about it.
Wait, 0 plus 3. Is it 3?
Yes. Just to be clear, this is a tricky one, and I want to make sure we know how to do this. So, we are adding two functions together. When you are taking limit of the addition of two functions, what you could do is split it. You take limit of the first function plus the limit of the second. So, we know this limit, well, x cancels out, it's just going to be 3. And then we already know limit as x goes to infinity of sine x over x is 0. So it will just be 3. Just be 3. Okay, so now maybe the next one you want to look at rule 3 from the top of the page. Who am I on? Hannah Fahuna? What about D? Oh, wait. Oh, hold on. I did not mean this.
How come it says what?
Limit as x approaches infinity.
Limit of x.
I'm not even done copying it down.
Okay, I'll give you like 2 seconds. Just kidding, 5 seconds. Here we go.
Did you skip like a bunch of people?
No, I'm going in alphabetical order. Anish, Karabat, Hamaides, Fahuna.
So you can factor it.
I will get to you.
One day you should do it the opposite.
I will.
You don't need to
Please.
get
I mean, last class we got through everyone and we started going through it again.
This one doesn't even say limits. Oh, so that was a mistake.
Yeah, but then the first alphabetical has to do it.
I'll mix it up. Don't worry. Okay, do we have an idea how to do this, Hannah?
Yeah.
We can skip you if you're not ready. Okay, you know what? Skippy time. You wanna do it? No. Yeah, I'm gonna do it. Skippity skip time. That way we make sure we do it.
Danish got it.
What?
Danish knows.
Do you? No, you don't.
Yes, he does.
I know.
Yes, he
What?
does.
Mr. Bryan, I
He
know.
does.
Mr. Bryan.
So much stuff. He got it. Is it Argo?
Is it 4?
Is it
What is
infinity?
0?
Yes, he knew it.
Whoa.
It's 4 times.
It's 4.
That was Danish.
Okay, so
Which is 0 plus 4 x squared over x squared, which is 4, and 0 plus 4, which is 0.
So what we see is we are taking limit of two functions being multiplied. When you have two functions being multiplied, and you're taking limit, what you can do is take limit of the first and multiply it by limit of the second. So that's what I'm going to do. I'm going to take limit of the first multiplied by limit of the second. So 4x squared minus 1 over x squared. Okay, so here as x goes to infinity, 1 over x plus 1. Well, that's just going to be 0 plus 1 times, because as x goes to infinity, 1 over x gets closer and closer to 0.
Oh.
What's up, Khalil? And then the other one, guess what? I can do leading term test. So 4x squared over x squared is just going to be 4. And if I multiply them, I have 1 times 4, which is 4.
Okay, what about the minus 1?
Leading term test. Leading term test here.
Ignore the rest?
So here, leading term test. Because we're going towards infinity, so that's when you use this test. Only when x is going to infinity or negative infinity. Because if you think about it, what really matters, right? Infinity, a big number, squared, or the plus 1. Like the plus 1 is minuscule versus the like 50 million squared. Like, nah, the plus 1, who cares? Right? That's why the leading term test is like what dictates, what is king of the hill at the end as x is getting bigger.
Then why is the plus 1 on the left side?
Okay, so let me split this one out a little bit. So wait, if I take limit of the addition of two functions, what I can do is take limit of my first one plus limit of my second one. Wait, limit of a constant is the constant. We know limit of 1 over x, bigger degree, bigger exponent on bottom, because there's no x on top, there's an x on bottom, that goes to 0, and that's why I can add them. The sum rule of limits. The sum rule property of limits. That's why. That's why. Okay. Infinite limits as x approaches a. Okay. If the values of the function exceed all positive bounds as x approaches a finite number a, we say that the limit is infinity. Cool. So if it's going up towards infinity. If the values exceed all negative bounds, aka it's going down, down, down without stopping, not even approaching a number, we say it's going to negative infinity. It's also correct to say it does not exist. This is why we could say positive infinity does not exist, negative infinity does not exist. So here's our first example. Let's go to Shani. A, limit as x approaches 2 from the left side. What is it going closer to? If we have our calculators, what does it look like? It's going down to negative infinity.
Can you give us a question?
So we say it does not exist.
Can you give us a question? So we're going to be able to allow these as calculators?
So, just like, as soon as we get through the lesson, I'll answer questions with the quiz. What? I don't know, you said to me. Okay. So, negative infinity, DNE, cool. So what's the limit? So, what does it say? Use graphs and tables. So what you can do is use a graph. How do you get a graph of this? Your calculator. Cool.
Wait, I'm looking at it.
Uh-huh. And as we approach 2 from the left side, from the negative side, it's going down.
Oh, I see.
As we approach 2 from the left side, we see it's going down. This is the part we care about.
So there's no work we would show.
Right here. No. All right, limit of int x over x. Pretty sure it's just a step function. It's like cast it as an int. It's the floor function? No. Okay, do I need to show you what this is?
You just tell us.
It's here. Where's in? It's positive.
It's not a trick thing. Is it a
We have.
Oh, maybe
Create a
it's
slider.
It's not a Python.
Is
I wonder if
there a slider?
it has to be booked. Everything will work.
She's doing that.
No, it asks you to make a
Why
slider.
did you do that? Wait.
Picture you what?
It asks you to make a slider.
Where did you get the word in?
I wrote it out.
Slider.
Oh, really?
You wrote it?
Yeah.
You wrote INT?
What?
The freak?
So that's crazy that it
Looks like a dragon.
Let me try.
So,
Only one way to find out.
Oh my god, I know.
so what this does, what int x does, is it literally casts it as an integer. If you've taken AP Computer Science last year, you should know.
I did.
I did it.
You should know what this means. When you cast as an integer.
I did it.
Read.
Why? What is this nonsense? Ready? I'm explaining it. I'm literally explaining it. I will not be able to contain my rage if I explain it, and then someone literally asked me the question I just explained because they weren't listening, because they were talking. That's so annoying. Like, why? Do you want to know what it means? I'm about to explain it. Okay, so what this does, if you took AP Comp Sci, when you cast as an integer, you just chop off the decimal place. So if I have 1.9, you chop off the decimal, it floors it. You just leave the integer part, the 1 part. If I have 2.567, blah, 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 you just chop off the decimal and it's left at 2. So literally between 0 and 1, what I'm doing, okay, cool, so you chop off the integer, I'm 0. Anything divided by a number is 0, so that's why the first line's 0. This second one, do you see where it's like a little curve? It starts at 1, then goes down. Imagine 1 divided by 1 is 1. Well, if I have 1.5, chop it down, make an integer. 1 divided by 1.5 is 0.67, so that's why about halfway through we're about at 0.67. That's why you have these little curves. What?
I get it.
So, because the top part is always going to be an integer. If I take 10.6, cool, I'm taking 10 divided by 10. If I take 10.7, I'm sorry, if I do 10.6, I'm doing 10 divided by 10.6. If I do 10.7, I'll do 10 divided by 10.7. Like, that's what this means. It's just a floor function. Making it an integer. Making it an integer value. Okay, so we see roughly what it looks like. What happens as we approach 0 from the left side?
It approaches infinity. Positive.
It was like this. So it was approaching infinity. So we say it does not exist. So why you have to use a calculator? Here it says use a graph or table. You look, as I approach from the left side, going to positive. So I'm looking for two things. I'm looking for the positive or negative infinity, and then you should say D&E. So I want you to write both. Because A, it tells me you know how to read up and down with your positive, negative. Then it tells me you realize infinity is not actually like a number you can pin down. It does not exist. So showing me those two things means you know it. Vertical asymptote. So we could have vertical asymptotes if we're approaching a certain number and it's going to infinity, like, oh, what we just did right here. We had a vertical asymptote at 0. Because if you think about it, 0 divided by 0 is indeterminate. That's no bueno. That's no good. So what we want to do is find the vertical asymptote of the graph and describe its behavior to left and right of the vertical asymptote. So it would be ideal if we could, cross anything out. That would be nice. So if on the top I have x minus 1, x plus 1, because it's a difference of squares. On bottom, I can factor out at 2. So we have a vertical asymptote whenever we're dividing by 0. So I'm going to take this part, and I set it equal to 0, because it cannot, I set it so it cannot equal to 0. So I see x cannot equal negative 2, and this is where my vertical asymptote is at x equals 2. Because when I divide by it, that would make it a vertical asymptote. So notice I was careful. I factored it out to make sure it doesn't just disappear. I had to make sure it was not a removable discontinuity, just a whole. It is negative 2. I wrote it up above. I just forgot to do it here. Good job. So I had to make sure it doesn't cancel out. If it cancels out on top and bottom, removable discontinuity, just a little hole. But if it doesn't cancel out and I'm left with a factor on the bottom, that's where your asymptote will be. Okay, so what if I take the limit as x approaches negative 2 from the left side? What would it be? And same way, if I took the limit as x approaches 2 from the positive side, what would it be? So if you put this into your calculator, so I see people not writing, which means they should be in their calculator graphing this and seeing what's going on. So there's a vertical asymptote at negative 2. So as I'm approaching it, am I going to positive or negative infinity? Well, which one? As I go from the left side, I'm going from the negatives, from the left side, from the negative, I'm going to negative infinity. As I come from the positive side, the right side, I'm going to positive infinity. exactly. This next one, well, let's see. Do we have enough time to do those? Yeah. Okay, so this one's gonna be very, very similar. Let's just do it really quickly. So 1 minus x over, if I factor out the bottom, 2x squared minus 5x minus 3. 2x plus 1 and x minus 3. So this time I have 2 vertical asymptotes because I have 2 factors that make me divide by 0. Oops. I have the vertical asymptote where I have 2x plus 1 equals 0. So that means I have vertical asymptote negative 1/2. And then I also set x minus 3 equal to 0. So I have another vertical asymptote at x equals 3. And then you use your graph and you say whether you're going to positive or negative infinity at these points. Because we know we have asymptotes. You just look at your graph and you say whether it's going up or down. Yeah, but I'm going to talk about the last page because your quiz is Monday and that's not moving. So, yep.
For A, how come you don't make 2 is not equal to 0?
How come I make 2? Sorry, what?
You only do it as an X.
This part?
Yeah.
Because I only want my vertical asymptote if like the bottom is going to 0, so I'm only look at the factor. I could have set 2x plus 4 and then I end up with the same answer of x can equal negative 2.
Oh.
So end behavior. So the end behavior for big numbers of x, we can model the behavior complicated function by using a simpler one. So literally, this is also leading term test. Looking at the biggest exponent on top, biggest exponent on bottom. Which one does this correspond to? So if I have a bigger on top than bottom, this means I'm going to infinity in both directions. So this corresponds to letter B.
Yes.
Versus if I have a negative x to the 5th and a divide by 2x second, I still have a larger exponent on top, but this effectively turns into negative 1/2 x cubed. For this one turned into 3x squared. So this one exactly is with A. Versus here, if I look, I'm having negative x squared. Oh, negative x squared just goes with C. So matching these up, if you use leading term test, it gives you the end behavior. You can see what your graph is going to look like. Okay, cool. Yeah, and lastly, it's just literally figuring out what would be the graph, the end behavior. So we see on both of on this one, there's no horizontal asymptote. And this one, the horizontal asymptote is at y equals 3.